Hello and welcome to Lesson 7 of Unit 2B, Quadratic Functions, Forms and Transformations in our Grade 11 University College Math class. This is Quadratic Functions comparing three forms. So we're now in Unit 2B. We're going to be exploring the different forms that our quadratics can take and then what those particular forms tell us about how we can graph those, graph the forms of those quadratics successfully. So we have three forms. One of them we just spent all of Unit 1 looking at, which is vertex form. So we're not going to spend a ton of time on that. The other two forms should be familiar to you from your grade 10 math class. So those two forms, of course, are factored form, which is f at x equals a bracket x minus r bracket x minus s, and standard form, which is f at x equals ax squared plus bx plus c. So there's a whole bunch of new variables we're introducing here, a couple new forms, probably a little rusty on these, so let's just jump right in with factored form. So what we're going to graph is over here. Here we have f at x equals x plus 2 and x minus 4. So what you want to remember about factored form is that it all is one term. The factoring reduces it to one term as opposed to multiple terms like you'll see in vertex and standard form. The piece of information that you get when you are working with factored form are the X-intercepts. Now the X-intercepts, as you can imagine, they always have a y component equal to 0. And what are those X-intercepts going to be? Well, if you recall that the parent function, or I guess the parent version of this function, is f at x equals a, x minus r, x minus s. You'll notice these come with negatives in them. And this is just like the bracket that we were working with that was a part of vertex form, where it comes with a negative. So it means that the numbers that are inside the brackets are the opposite of how they appear. So although this looks like a positive 2, it is actually x minus negative 2. And although that looks like a negative 4, it's actually x minus positive 4. So, opposite of how they appear, let's just jump right in. We'll get some points on here. This is going to then be negative 2 and 4. Okay, so let's get those 2 points on the graph. That's going to be x equals negative 2, so we'll put that over here, and x equals positive 4 right here. Now the other piece of information that we get in this form is the a value. Now the a value is equal to 1. It's just kind of invisible out front here. With an a value of 1, it means that our plot pattern of 1, 4, 9, when we go out 1, 2, or 3 units from the vertex, it's going to be multiplied by a, which is 1, which means that our plot pattern is going to be the one that we're really familiar with 1, 4, and 9 being our output values. That's helpful. The last piece of information we need before we start graphing is the vertex. So how do you find the vertex from factored form? Well, there's two ways to do it. The first way is to do it visually, because we know, because this is a symmetrical shape, a parabola, that our axis of symmetry is going to be halfway between these 2 points. And I can then sketch my axis of symmetry all the way top to bottom, no problem at all. And somewhere along this axis of symmetry will be our vertex. So let's label that x equals 1. Now, we can use this value for x of our vertex to find out what y is going to be equal to. So we can figure out what f at 1 then will be equal to, and that will give us the y component of the vertex. So that'll be 1 plus 2 and 1 minus 4. That's going to be 3. Working the brackets first, and negative 3, and then negative 9. So our vertex is actually going to be 1, negative 9. Another way to do this, and this one's an algebraic method for finding it, is basically the same thing that you just did with your eyes, where you know that the h component of the vertex, so the x part, is halfway between r and s. And we can do that mathematically by adding those two values together and dividing by 2. So the r value was negative 2, the s value was 4. We add those together, and we get 2 over 2, which gives us 1. At that point, we would substitute into the original equation and get the y component of the vertex. So 2 ways to do it. One is visually, and another way to do it is algebraically. So let's get that point on the graph. So we have 1, negative 9. There it is. Now from here, we're just going to be doing some plotting. So we know from the vertex we go out 1 and up 1, out 2 and up 4, 1, 2, 3, 1, 2, 3, 4. And we are now going to, and out 3, up 9 are points that we've already graphed. Those are our x-intercepts. So now we're just going to sketch this, try to make it as curvy as possible. Let's get some arrows on there. And now let's label some points. So we're going to start by labeling the vertex, as we do every single time. That's 1 and -9. Now, normally we would label 2 other points. This time we're actually going to label 3, and it's because both our x-intercept and y-intercept all go through integers or whole numbers based on our plot pattern. So let's start by labeling the y-intercept, which is right near here, at 0, -8, and our 2 x-intercepts, -2, 0, and 4, 0. So this is the method for graphing from factored form. Factored form provides you with the x-intercepts, the opposite of how they appear in the actual brackets, and it also provides you the a value, which gives you the direction of opening in the plot pattern. You can find the vertex visually by learning the axis of symmetry's value as halfway between the 2 x-intercepts, and then substituting that value into the original equation to find the y component of the vertex. The other way to do it is to use this little equation right here, which is y equals r plus s divided by 2. That is an algebraic way, or I guess a mathematical way, of figuring out what the h component of the vertex is. So there you go. That is how you graph from factored form. We're going to do vertex form and standard form in the next, actually, well, let's push forward. Let's do vertex form in this lesson too. Why not? It's not so long yet. So if we're talking about vertex form, which I think I did in purple, so vertex form has some information that's really helpful. Actually, this is probably the most effective form that we have, where we've got f at x equals a, let's write it out, I guess, f at x equals a x minus h all squared plus k. We can find the vertex right away. So the vertex we can get, that's the h and k value. So that looks like a -1, is actually a +1, and there's our -9. We also get our a value. Our a value, which isn't written but is right here, is a +1, which means that our plot pattern of 1, 4, 9 gets amplified by 1, which, as you can see already, doesn't impact the plot pattern. So from our vertex, we go out 1, up 1, out 2, up 4, out 3, up 9. So there you have it. Let's start graphing. So 1, -9, that's down here. From our vertex, out 1 and up 1. Back to the vertex, out 2, up 4. And then back to the vertex, out 3, up 9. And now we put some lines through it, keeping it as curvy as possible. There we go. Let's get some arrows on that. Let's get our axis of symmetry on. So our axis of symmetry goes through the vertex, all the way top to bottom. And we are going to label it. As I said, I like to label it at the bottom. You don't have to do that. You can also equally properly label it at the top. I'm going to label it at the bottom. X equals 1. And now we are going to label some points. So the points we're going to label here are vertex, 1, -9. And again, we have both the y-intercept and the x-intercepts available for us to label. So this is that instance where you would definitely label 3 points, 3 additional points other than the vertex, as opposed to 2. So there we go, -2, 0. And that is our vertex form quadratic. Actually, you know what? I should also be labeling the equations on these as well. So let's do that before I forget. F at x equals x, what did we have there? X minus 1 all squared minus 9. And let's do the one up above as well. That was f at x equals x plus 2, x minus 4. All right, so there are the first 2. Factored form, which should be a fair bit of review since you probably haven't looked at it in a long time, and vertex form, which is the one that we worked on in the last unit. In the next half of this lesson, or the next part of this lesson, we'll work on standard form, and just do a bit of a summary. So we'll see you in part 2.